Hi, hello everyone. This is Yuva. Welcome to my ఛానల్. ఈరోజు మనం ఈ క్లాస్లో ఆర్గానిక్ కెమిస్ట్రీ రియాక్షన్ మెకానిజం లెర్నింగ్కి కావాల్సిన బేసిక్స్ అయిన రియేజెంట్స్ గురించి క్లియర్గా డీటెయిల్గా మనం ఈ క్లాస్లో డిస్కస్ చేసుకుందామా. మరి క్లాస్ స్టార్ట్ చేసే ముందు అందరికీ ఒక చిన్న రిక్వెస్ట్, నా ఛానల్ని ఫాలో చేయండి, సబ్స్క్రైబ్ చేసుకోండి, షేర్ చేయండి. సో కెమిస్ట్రీలో బేసిక్స్ గురించి, బేసిక్స్ దగ్గర నుంచి క్లియర్గా డీటెయిల్గా మనం ప్రతి చిన్న టాపిక్ కూడా చాలా క్లియర్గా పర్ఫెక్ట్గా డిస్కస్ చేసుకుంటున్నాం. ఇది మీ యొక్క కెమిస్ట్రీ బేసిక్స్ బేస్ చేసుకుని మీ ఓన్గా మీరు ఈజీగా ఏ టైప్ ఆఫ్ క్వశ్చన్స్కైనా 100% పర్ఫెక్ట్గా సాల్వ్ చేసే విధంగా నా యొక్క క్లాసెస్ ఉంటాయి. సో నా ఛానల్ని సబ్స్క్రైబ్ చేసుకోండి, కెమిస్ట్రీలో గుడ్ స్కోర్ సాధించండి. రైట్, మరి క్లాస్ స్టార్ట్ చేద్దామా. ఇన్ లాస్ట్ క్లాస్ we discussed the type of fission or type of cleavage of a covalent bond. In previous class we discussed that bond fission is two types. Bond fission is two types. One is homolytic, another one is heterolytic, right? Homolytic fission and heterolytic fission, right? And in case of this one, homolytic fission, you know very well, if you take a same type of atoms when involved in homolytic fission, then they produce radicals. Which are called free radicals, right? Free radicals, right? And heterolytic splitting, if I take a bond between two different atoms, heteroatoms, at that case they were completely, because of complete transfer of electrons, they convert as charged species, nothing but ions, either positive, either A plus ion and B minus ion, or A minus ion or B plus ion. So now from that onwards we have to continue the topic. In this topic let us discuss what are the charged species, what we have to say them. Here charged species either may be positive charged or negative charged or free radicals are very important for learning of the organic reaction mechanism. And first of all, let us discuss simply the basic term electrophiles. What is electrophile? One of the most important is electrophile. Here electrophile we indicate as E+. What are called electrophiles? Electrophiles are positive charged species. Very good. And they are electron deficient species. These are electron deficient species. Simply electrophiles means these are electron deficient. Electrophiles are electron deficient. So these electrophiles are electron deficient. That's why they attacks at high electron density site. So electrophiles are electron deficient species. Nothing but nucleus rich. They are having higher. They require electrons. That's why they attacks at a high electron density site. Now simply electrophiles, the name only, electrophile means electron deficient. That's why they are attacking at high electron density position. High electron density position. Now let us discuss some example for the electrophiles. How many types of electrophiles we have? We have two types of electrophiles. We can discuss two types of electrophiles. So electrophiles are nothing but electron deficient species and they attacks at high electron density site. Now let us discuss electrophiles two types. One is positive charged type electrophiles. Positive charged type electrophiles. All positive charged charged species acts as electrophiles. But here one exception is there. Here what is that exception? Except 1A and 2A group, 1A and 2A group elements species. What is the reason, sir? 1A group elements positive charged species not acts as electrophiles in this case. Here all positive charged species acts as electrophiles. Let us discuss some examples. So 1A group elements and 2A group elements positive charged species, even though they are positive charged, but they are not acts as electrophiles. That is, see, simply in this case H plus, Cl plus, Br plus, I plus, OR plus and R plus, NO plus. See, H plus, Br, Cl plus, Br plus, R plus, I plus, OR plus, R plus, NO plus, NO2 plus. We can take NO2 plus and CH3 plus, C2H5 plus, R plus, all etc. All positive charged species acts as electrophiles. So are they having electron deficiency? That's why they are behaving as electrophiles. And what is the second case? In this case, keep in mind 1A group elements and 2A group elements, they even though having positive charge, they doesn't act as electrophiles because they are having octet configuration. They are not ready to take the additional electrons, right? And in this case, neutral molecules with empty orbitals on central atoms acts as electrophiles. Let us discuss some example for this. Yeah, if you can take BeF2, BeCl2 and BeCl2, BCl3, BBr3, like BCl3, AnCl3, FeCl3, SnCl2, SnCl4, SnCl4. All they can act as electrophiles. They are having all Lewis acids, acts as here electrophiles. So, my dear students, electrophiles are two types. Right? Before going to that, electrophile is nothing but electron deficient species which attacks at high electron density site. So electrophiles, whatever, if you take any type of electrophile, maybe neutral electrophile or charged electrophile. So electrophiles mainly we classified as two types. One is charged, another one is neutral. All positive charged species acts as electrophiles except 1A and 2A group elements. Except 1A and 2A group elements are very important. Right? And see, these are neutral molecules which contains vacant orbitals. They also act as electrophiles. This is about electrophiles. Simply, electrophile is a positive charge species which attacks at a high electron density site. If you take any molecule, something, for suppose for understanding purpose, I am taking like this. In this case, this lone pi bonding electron move toward this side. Whenever these electrons are moved toward this side, the electron density on this oxygen will be more. At that case, this electrophile attacks on this oxygen. Simply, we can represent as OE. By the loss of electron, it converts as like this. Whenever these pi bonding electrons are shifted toward this side, the electron density on the oxygen will be increases. This bond will be converted as minus charged species and plus charged species. At that case, this electrophile attacks on this high electron density side. Similarly, if you take an electrophile, if it is with unsaturation containing compound, at that case also, if you see, if these pi bonding electrons are moved toward this side, at that case the electron density on this carbon will be high, and at that case this electrophile attacks at this position, and simply it will be converted as like this. Right? This is positive charge and like this. So electrophiles attacks at high electron density site. Now let us discuss about nucleophile. See, nucleophiles. Nucleophile simply we indicate with Nu minus. Nucleophile simply we indicate with Nu minus. Actually, nucleophile, if you see what is the charge on the nucleophile symbol, minus charge. That means these are electron rich species. Electron rich species and nucleus deficient species. Nucleus deficient, right? Nucleus deficient species. Simply, nucleophiles are electron rich and nucleus deficient species. Then these are attacks at a less electron density site. These are attacks at less electron density site. These are attacks at less electron density site. Simply you can also consider less electron density site means either you can also consider as positive site. They can also consider as positive site. So if you take any covalent bond, when the bond is involved in heterolytic splitting, for suppose I am taking like this bond. In this case, if the bond involved in heterolytic splitting, at that case they simply forms a plus and X minus. Simply this is called nucleophile. And these are also two types. Nucleophiles are two types. Like electrophiles, these are also two types. What are them? First one is negative charged negative charged species. You can simply remember all negative charged species acts as nucleophiles. All negative charged species acts as nucleophiles. You can see all negative charged species, whatever it may be, either తీసుకోవచ్చు. Either, let us discuss some example. H minus, F minus, Cl minus, Br minus, I minus, Cl minus, RO minus, OH minus, RCOO minus, RCOO minus, RNH minus, RNH minus. You know, any type of compounds, either you can consider either any type of, in this case, NH2 minus and SH minus, RNH minus are united. So sorry, R2N minus, etc. All they can act as electron rich species and they also act as a nucleophiles. Simply all negative charged species are acting as nucleophiles. So and second type of examples, in this case electron rich species. So means electron rich species. And second type of nucleophiles, neutral molecules with at least simply we can define as one or more number of lone pairs on central atom or acts as nucleophiles. So nucleophiles means, here in this case we are discussing neutral molecules which are containing one or more than one number of lone pairs on the central atom. They also acts as a nucleophiles. For suppose I am taking simply NH3. This one contains one lone pair, and H2O. This oxygen contains two lone pairs. Similarly, you can take alcohol, ROH. This contains two lone pairs, and thioalcohol. It is also contains two lone pairs, right? RNH2, amine. It is also contains lone pair. So lone pair containing neutral molecules which are contains one or more than one number of lone pairs on the central atom. They also acts as a nucleophiles. And like previously, here also I'm discussing nucleophile. It is attacks at less electron density site. I am taking this is a carbonyl group, right? When this carbonyl group containing pi bond shifted towards this oxygen side, at that case it will be gain minus charge, it will be gain positive charge. Here this nucleophile attacks on this carbonyl carbon containing positive side. So always nucleophiles attacks at less electron density site. Like this type of attacking takes place. If I take nucleophile and if I treat with for suppose I am taking cyanide, I am taking Cn minus. If I treat with carbonyl carbon, this bond will be shift towards this side. This carbonyl carbon attacked by cyanide ion and simply forms O minus and Cn. This type of attacking will be takes place. Means Always nucleophiles attacks at less electron density site or positive site. From the definition, we are explaining this simple reaction mechanism. This simple reaction mechanism, right? And already you know very well, all Lewis bases acts as nucleophiles. All Lewis bases acts as nucleophiles. All Lewis acids acts as electrophiles. So, మరి ఈ క్లాస్లో ఎలక్ట్రోఫైల్స్ న్యూక్లియోఫైల్స్ గురించి డీటెయిల్గా డిస్కస్ చేశాం కదండి. మరి నేను మీకు అందరికీ అర్థమైంది అనుకుంటున్నాను. Let us discuss free radicals. In the previous class already I explained, but one more time I am explaining that free radicals also, these are formed by the homolytic splitting of covalent bond, right? I am taking one simple example. I am taking hydrogen covalent bond. If I apply sunlight, in presence of sunlight or in presence of peroxides also, you can take peroxides, simply it will be forms free radicals. Similarly, if I take a covalent bond between two chlorine atoms, let us discuss one more example. I am taking chlorine molecule in presence of sunlight. It will be involved in homolytic splitting. It will be converted as a free radicals. These are called free radicals. So these are free radicals. These are most reactive species and unstable. These are unstable and these are electron deficient. Right? Now let us discuss about one special type of species, which are amphiphiles. One of the important amphiphiles. From this term, we can simply say the species which are acts as electrophiles and nucleophiles. Simply, amphiphiles are nothing but the species which acts as both electrophiles as well as nucleophiles. Depending upon which acts as electrophiles and nucleophiles are called amphiphiles. Depending upon the situation, they can act as electrophiles and they can act as nucleophiles. మనకు ఒక అవసరాన్ని బట్టి అక్కడ ఉన్న అవసరాన్ని బట్టి అవి ఎలక్ట్రోఫైల్గా బిహేవ్ చేస్తాయి, న్యూక్లియోఫైల్గా కూడా బిహేవ్ చేస్తాయి. Compounds with most electronegative atoms like oxygen, nitrogen, sulfur. Those compounds which are contains oxygen, nitrogen and sulfur with multiple bonds can act as amphiphiles. Best example here, you can take RC double bond OH. Is this molecule containing double bond or not? Aldehyde. This molecule containing aldehyde. So can we call these are amiphiles? RC double bond O and RCOR, RSH and RCSH like this. RCSH and RCN, or you can consider RCN, RCONH2 amides, nothing but RCONH2, right? Means aldehydes, ketones, esters, thiocarbonyl compounds, and also amides. All they can act as a amiphiles. Means simply amiphiles are nothing but some of these molecules or species which can act as a electrophiles and nucleophiles. They are simply called amiphiles. మరి ఈరోజు మనం ఈ క్లాస్లో డీటెయిల్గా ఎలక్ట్రోఫైల్ గురించి, న్యూక్లియోఫైల్ గురించి, ఫ్రీ రాడికల్ గురించి, యాంబిఫైల్స్ గురించి క్లియర్గా నేర్చుకున్నాం కదా. మరి నా ఎక్స్ప్లెనేషన్ మీకు సాటిస్ఫాక్షన్గా అనిపిస్తే మరి నా క్లాస్ని లైక్ చేయండి, ఛానల్ని సబ్స్క్రైబ్ చేసుకోండి, మీ ఫ్రెండ్స్ అందరితో షేర్ చేసుకోండి. మీ ఫ్రెండ్స్ అందరికీ కూడా కెమిస్ట్రీలో మంచి మార్క్స్ రావడానికి హెల్ప్ చేయండి. థ్యాంక్ యూ. ఛానల్ లైక్ చేయండి, షేర్ చేయండి అండ్ సబ్స్క్రైబ్ చేసుకోండి. ఛానల్ లైక్ చేయండి, షేర్ చేయండి అండ్ సబ్స్క్రైబ్ చేసుకోండి.